Okay, let's get that learning goal down, simplify that problem. That'll be this will be kind of our branch to hang on to as we go through today's stuff. Okay, we'll be going through 8.4 and 8.5 this week. Notice that takes all week to get through those two. 8.6 next week test, and we'll be ready to roll after spring break into our actual trig. Okay, so give yourself a minute here to fill that out. Are done with this problem. So some of us didn't start it though. Hey, this shouldn't be a tough problem, I'm hoping. Okay, first, the reason I have it up here is so that we review how to cross-cancel, how to reduce. Okay, remember you can simplify fractions by reducing them. What goes into 8 and 14? 2. How many 2's come out of 8?
4.
How many 2's out of 14?
7.
Okay, and 12 and 35?
No.
Nothing. How about 4 and 12?
Yes. 4.
Yeah, 4 goes out of there once, and 3, 7 and 35.
Dude, 5 times out of 35.
What goes into both?
7.
7. Once here, and
7.
5. So now that we're done, multiply straight across. 1 by 3 is?
3.
And 1 by 5 is?
5.
3/5. Okay, now we're going to be doing that today with linear and quadratic expressions in the numerator and denominator. Okay? So, why don't you go ahead and study example 2 on page 371, answer questions 3 and 4. So number 3, why does the solution for example 2 exclude x equals -4? Volunteer. Noel?
Because in the solution, it's x plus 5 over x plus 4, and -4 and -5 are the opposites.
Okay, so these right here, I think what you mean, you have x plus 4 and x plus 5 on the bottom. Okay, and so -4, what does that make this? 0. Okay, which would make this undefined.
Yeah.
Right? And why does it exclude -5? Same thing right here. That would make that 0, which would make this undefined. If I put -5 in right here, I get that 0. Okay, so those are discontinuities. Right? Okay, in this case, what's my whole?
-5.
-5 is the whole. Why is -5 the whole? Jada?
Because on the top you also cancel out x plus 5, one of the x plus 5.
Good. Yeah, that's our removable piece. So quick review on that. Any questions there? Okay, number 4, simplify each expression. Well, first thing, it's a little easier if we start looking at these as different problems. If you struggle with it, some of you will just look at it and you'll be able to simplify it, no problem. If you struggle a bit, try to look at this, say, as numbers and numbers, especially when there's only multiplication signs here. If they're addition or subtraction, then it's a bit different, but we have -27 over 9, which we can reduce. Is that reduced to? Good. -3 over 1. Okay, 9 goes into both. All right, and then we have x cubed over x to the 4th. Where do you have more x's?
On the bottom.
On the bottom. How many more?
1.
One more on the bottom. So we have x to the 1st on the bottom. What do we have on top?
1.
Yeah, it's not 0, it's 1. Okay, so we're multiplying that. And then we have y over y, and they cancel. Okay, so that just becomes 1 over 1, which we don't worry about. So, grand scheme of things here, we have -3 times 1 times 1, or -3. Okay, and we have 1 times x times 1, which is x. -3 over x. Questions on A? Okay, B. We should always try to factor. Okay, you can't just cancel individual pieces. So the common mistake is this. I'll cancel the 6's, and I'll start canceling some x's. You can't do that. Okay, remember, this is a grouping. Okay, this is like you and your buddies going to the movie. You don't leave a buddy behind, dude. You don't just like cancel one out and say, okay, you're out. Okay, all right. You got to stay in groups. Okay, so this group becomes 2 new groups. When we factor it, what do we get?
No. X minus 2 times quantity of x minus 3.
Okay, x minus 2 times the quantity x minus 3. All right. Yeah, be careful with the 5s and 6s. Okay? How about up here? Can we factor?
No?
Well, yeah.
We could actually rearrange it first, right? Negative 3x plus 6. Pull out a 3. Good. So that, pull out a negative 3. Good idea. Negative 3 times x minus
2.
2. Okay? So, with that, that allows us now to
Cancel.
cancel the x minus 2's. Okay, so we get what on top?
Negative 3.
Negative 3 on the bottom.
X minus 3.
X minus 3. Now, you need to list restrictions here. That means what could x not be? So in this one, x cannot equal, yeah?
3.
3. What else? Or 2. At any point, if it'll make a 0 on the bottom, you've got to list it as a restriction. So it can't be 3 because that'll make 0. And it can't be 2 because that'll make a 0. Those are our restrictions. If it is, then it's undefined. So we didn't list a restriction over here. We should have. What can x not be?
0.
X cannot equal 0. Do we have any other restrictions? Yeah, y can also not equal 0. Okay? Because if y is 0, we get a 0 down here. All right. So list those restrictions. Okay, make sure you note that in your notes there. Okay, any questions? How many got that on letter B? How many forgot a factor at the top? Okay, well now we know. Good. That's why we go through it first. Letter C. Hey, we have those 5s and 6s again. It actually ends up being the same thing though, right?
Yeah.
X minus 2, x minus 3.
Correct.
How about the top?
What about it?
Can't factor it?
No, you can.
No, you can.
You can?
Yes, sir. Like,
Okay. What did you guys get? Uh-oh. Well, you guys better factor it then. What do we get? Jacob?
I got 2x plus 1 equality, and then x minus 2.
Okay, and so now I'm checking. That's negative 2. That's 2x squared. That's 1x. And that's negative 4x. Good. All right, so that works out. Well done. If you need help with factoring, you need to get in here and get help. I just assume that you can do it now. Okay? Those two cancel. All right, we're left with
2x plus 1 over x minus 3.
2x plus 1 on top, x minus 3 on bottom. Okay? And our restrictions, x cannot equal
2 or 3.
2 or 3. All right, any questions? All right, moving right along. Okay, example 3, page 372. Complete questions 5 and 6. Ready to go. Hey, can I have everyone pause for a second, please? Hey, let's take a look at 5, and then I want to give you a hint on 6. All right? To begin with, for which values of x is the product in example 3 not defined? As you're looking through example 3, which I put up here, you start looking through it. As soon as you factor the denominators, at any time on the denominator, if you can put something in for x and get a 0, then it's undefined. Those are restrictions. So right here in the second step, x can't be 4. X here would equal, it would make 0 at negative 3, so it can't be negative 3. And it would make 0 here at negative 5, so x cannot be negative 5. Those are our restrictions. Okay? Good? Questions on that? Okay, looking at number 6, for those of you that have struggled beginning, I heard a few of you struggling, start by factoring the numerators and denominators. Factor completely on everything, and then try canceling. Keep working at it. So I wrote it out here. This cancel, or this factors to,
Uh,
good, a plus 2, a minus 2. What is this factor to down here?
A plus 1, a minus 1.
Good, a plus 1, a minus 1. Most of you are doing fine with those. Difference of two perfect squares. This is, you may just want to put parentheses there just so you can see the grouping. Okay? But then we look at the a squared plus 2a. Some of us were struggling with that. What comes out of both of those? A, good. A times what is a squared? And a times what's 2a?
2.
Good. So now the denominator is all factored. Before we cancel anything, let's list our restrictions.
Oh.
Here, what makes 0?
Negative
Good. So a cannot be negative 1. What makes 0?
1.
1. So let's put plus minus 1. What makes 0?
0.
Yeah, 0 right here, right? A cannot equal 0. And
negative 2.
a cannot equal negative 2. So those are all of our restrictions right there. Okay, it cannot be any of those things. All right, now we start canceling. You can cancel
A plus 1 and a plus 1. A plus 2 and a plus 2.
Good. So on the top we have a minus 2 left. On the bottom we have
A minus 1.
good. Can we just cancel these a's?
No. They're grouped.
Yeah, it's grouped on top. Okay, you can't leave your buddy behind, dude. Right? Don't just get rid of one. All right. This is your solution.
I knew it.
If you wanted to multiply out the denominator, you could, but we're going to leave it like that. Questions?
No.
Alrighty.
All right, here we go. Back down, last piece. I want you to go into example 4, page 373, answer questions 7 and 8.
I keep
Here
writing
we go.
like
On number 7, I've actually flipped it already here, but the original problem, this was on the denominator, right? At any time during the problem, if you can make a 0 on the denominator, that's part of your restrictions. So here you have a lot of restrictions. We have x cannot be negative 2/3 from that quantity, cannot be 2. It cannot be 4. And this, the problem actually started with this down here, right?
Mm-hmm.
It started on the bottom. We flipped the fraction, so x cannot also be
2.
and it cannot be
5/7.
5/7. That is a lot of restrictions, man.
Yeah, man.
Right? Because this started on the denominator.
So on number 8, you have the multiplication.
Yeah. Oh, y. Sorry. Good call. Y cannot equal 5/7. Okay, let's do some canceling. Yes? Right, but when you divide, you flip it, right? Brooks, pay attention. Yeah. So
You can write x cannot be 2 both times.
no, you only have to write it once. Yeah. You only have to write x cannot be 2 once. Okay? At any point during the problem, if you can make a 0 in the denominator. So up here we started with this on the bottom and then we changed it to multiplication and flipped it. That's why. Okay? Okay, these are going to cancel. Right? These are canceling. Anything else canceling? No? All right. So on top we're left with, you know what, I'm going to write it over here. Negative times 7y minus 5. And we get 3x plus 2. Anything else? Yeah, we have that 5 hanging there, right? We could write it like that. It'd probably be better if we actually write it as negative 7, the quantity 7y minus 5 over the quantity, or over 5 times the quantity 3x plus 2. Okay, and once again, I know that